Hi, welcome to the webinar. Before we begin the formal presentation, I just want to take you through some of the features of this webinar platform. So all participants are muted on entry to the call. If you have a problem, please use the question fields in the panel on the side of your screen and we'll try to help you with any technical difficulties or queries. We'd also like to encourage you to ask us all questions throughout the presentation. So please use that same question field that's on the side of your screen and type in any questions that come to mind, either during the presentation or even when we have the question and answer session. You'll also find some resources in the handout section, so please have a look at those. And lastly, we'll be in touch to send you a recording of the webinar and the accompanying slides as well. So good morning and good afternoon. Welcome to the Global Prior Art and Cipher webinar on Next Generation LiDAR for Automotive, Understanding the Implications of Rapid Change. I'm Francesca Lavoie and I run the marketing team at Cipher, and I'm delighted today to be joined by a good number of members from the Global Prior Art team, by Bruce, Brendan and Benedict. So thank you for joining us today. Bruce, can I hand over to you to maybe introduce yourself to everyone on the call?
Yes, thank you, Frankie. Hi, everyone. I'm Bruce Frubinger, the Managing Director and the founder of Global Prior Art. My background's a blend of technology and decision analysis. I've got a bachelor's in EE, master's was in controls, PhD was in system science, and this is the 40th anniversary of Global Prior Art, and so over that period, we've done a lot of really innovative things. We're known often for our deep technology bench, but we've also been pathfinders in terms of decision analysis, helping companies create strong portfolios, and many other things that we've done. One of my key interests is really best practices in IP management. I've done a lot of work in that space. I've worked closely with companies trying to understand the opportunity space and capture it with new processes and decision tools. And I've written extensively on that in intellectual asset management. And that should give you just a little background about my work. Let me turn it back over to Frankie.
Great, thank you, Bruce, for that introduction. Brendan, could I ask you to introduce yourself, please?
Yeah. Hi, good day, everyone. My name is Brendan Cipher, and I work alongside Bruce at Global Prior Art. I've been working with him for over 15 years now, helping lead the efforts of our semiconductors and electronics team. My background is in sensors and chip design, and our group does a lot of work in the areas of optoelectronics, sensor systems, optical design, and vehicular electronics.
Thank you, Brendan. And Benedict, could you give us an introduction to yourself?
Yeah, certainly. Hi, I'm Benedict Bichele. I'm a senior member of the semiconductors and electronics team here at GPA. My academic background is in microsystems engineering with a focus on optical engineering. And alongside Brendan and Bruce, I've been working on a lot of LiDAR and driver assist related matters over the years. And yeah, we're excited to talk about some of our insights from our research and collaboration with Cipher on this topic today.
Great, well, thank you all for that. And I think it's wonderful to hear that we have so much experience in the room here. We've got an hour together today, and I just wanted to set up the main aims that we're hoping to achieve across the hour. We are launching a study in the automotive LiDAR space, and we want to tell you about that study and how we have a unique approach to that. We also want to share with you some of the initial findings that we've had around the rapid changes in the space. So that's what we'll hope to get to by the end of the hour. To get there, we're just going to cover the following areas. So first of all, we're going to look at getting to grips with the automotive LiDAR space, and Brendan's going to take us through that. Then we're going to look at the accelerating pace of innovation and the change that's happening in the space, and Ben is going to take us through that. Then I'll take you through how Global Prior Art and Cipher are working together to address this rather large, complex technology area. And then Bruce is going to take you through some of the benefits that we feel everyone will have if they sign up to our study. And then we're really looking forward to answering some of your questions. So please do keep them coming in the question field. So I'll hand over to Brendan, who's going to talk about getting to grips with the automotive LiDAR space.
Great. Yeah, so in partnership with Cipher, our team has been working on following and tracking developments within the LiDAR space. Specifically, we've been working on a couple fundamental architectures of LiDAR sensors for the first phase of our study, looking at beam steering technologies. LiDAR is a really exciting technology that we see coming into play with next generation vehicles, helping increase safety with driver assist systems, and helping to enable future cars to achieve higher levels of autonomy. LiDAR is one of many sensors, and a particularly new one for vehicles being used to get higher perception around a vehicle. LiDARs are used to get depth information and 3D information of the surroundings of vehicles, which is much more detailed than current day radar or ultrasonic sensors that are commonly employed. Very exciting technology that is developing rapidly and getting a lot of attention as higher levels of driver assist technology are introduced and the push towards autonomous vehicles is taking place. So with our study, we're following this and looking at some of the key technologies driving these changes. Using Cipher's patent classifier tools gives us the ability to rapidly analyze new developments, especially in the IP space, where we see thousands of patents being filed from around the world. Just in the last couple of years, the filings have really accelerated. We first started looking at autonomous vehicles and LiDAR as early as 2016, looking more broadly at autonomous vehicles, and then more narrowly at LiDAR in 2018. I think we published, Bruce and Ben and I, on LiDAR at that time in 2018, taking a snapshot and some initial thoughts on where it might be headed. Since then, we've seen rapid increase in the technology and some new technologies emerging, as well as many new players entering the field. Next, I wanted to talk a little bit more specifically about the areas that our study is currently focused on. I mentioned earlier there in passing that we're looking at beam steering approaches at the moment. Sensor design for LiDAR can be divided up in sort of 5 main categories of how the light is steered in the LiDAR system. There's a lot of variation within these, but building classifiers around these 5 fundamental architectures helps us get a very interesting look into the space. There's 2 main branches, one being a larger mechanical spinning LiDAR approach, where we see entire housings being rotated, we call it a rotating platform, and allows the light to scan all around the vehicle, get a 360-degree 3D view of the surroundings. Another approach, similar but different, is where only the optics of the unit are rotating and the electronics, circuit board, for example, and detectors and light emitters are fixed. That also allows scanning around the vehicle and 360-degree field of view. Newer approaches that we see emerging rely on solid state solutions, kind of emerging from these scanning optics and rotating platform is the MEMS solution, where it's kind of a miniaturized optics where you have solid state array of MEMS mirrors helping guide the light. Further approaches have no moving parts, like the optical phase array approach and the flash LiDAR architecture and OPA, optical phase array. We still see the light being steered, but rather than using optics to do the steering or movement, phases, electric phases of how the light emitting diodes are driven are timed such that the interaction causes the light to be emitted in different patterns and allow a scanning across a field of view. And the final one, flash LiDAR, is actually just a fixed scan where it just does a flash, like a flash on a camera, and captures a single image in front of a solid state imaging sensor. While that doesn't allow a full field of view, many of these could be arrayed around a vehicle, or they could be used to fill in gaps of some of the other solutions. It's a very interesting approach to LiDAR that is really gaining more and more traction, and you see a lot of interest in as it complements some of the other approaches and offers some unique solutions to problems being faced as people are introducing these into cars. Each of the different platforms for beam steering have certain advantages, and there's trade-offs with selecting each one. The rotating platform and the rotating mirror tend to be larger in size and have more moving parts. That can lead to higher costs, certain issues arising with calibration and alignment. We see a lot of solutions for those issues in new IP that's coming out. The cost has dramatically been driven down as the interest in LiDAR has increased. And so these are much more affordable than when they were first being produced in the early 2010s, say. Now they can be manufactured in much higher, on a lot larger volumes, work more reliably, and are lower cost. But there's still tend to be more expensive and have, you know, the typical pitfalls that you find in any sort of mechanical system, especially with harsh environments like a car might endure. So solving some of those issues, we see that these new solid state solutions coming into play, less and less moving parts, essentially no moving parts for the optical phase array and flash architectures, as they're just chip designs. MEMS mirror, there is mechanical movement, although at a very small scale, and they have their trade-offs. So mentioned there that flash only captures the field of view right in front of the sensor, has no scanning. OPA, while it has scanning, is still limited in the field of view since it's facing one direction. MEMS mirror can grab a larger field of view, but also not as wide as the others. And the cost can add up if you do have to rely on multiple of these. So what we're seeing is more of a hybrid approach and sensor fusion of not just different types of sensors, but even different types of LiDAR being used in tandem to stitch together a field of view around the entire vehicle. Other differences in approaches and reasons for selecting different architectures that we've seen are different applications and different technical problems being solved. So for different vehicles, for example, trucks or buses versus vehicles, they encounter different environments and have different utilities. And so the need for a full 360-degree view is maybe not as necessary, for example, for trucking, whereas for vehicles that are often in urban environments with lots of pedestrians, really need to have that higher level of perception to properly address safety and control of a vehicle when you're talking about higher levels of autonomy. So there's different reasons for selecting the different architectures, and we're investigating all of these in parallel. So we've started talking to various participants in the study about what they'd like to learn from our efforts and our analysis of the space, and what their goals are, in addition to what additional areas we should look at next within LiDAR. Some of the goals that we've heard from the participants, a lot of technical, what technologies are lower cost, what approaches are helping drive down the cost, always important in a commercial setting, which solutions look to be more amenable for a higher volume production. Certainly for commercial vehicles, where you're talking about tens of thousands of vehicles versus perhaps some other applications like taxis or buses, where there's going to be a slower rollout, say. There's different interests in the volume and availability for high volume of the different approaches. And sizes and look of the different sensors is important. The aesthetics, can impact the success of sales of the vehicles, and we see, the cars on the street that are fully autonomous with the spinning LiDAR on top looks quite a bit different than what people are used to, and so for commercial vehicles. There's a lot of other vehicles we might point to, like police vehicles, emergency vehicles, where you see roof-mounted objects. So those applications, perhaps that aesthetic is not as concerning, but high-tech commercial autonomous vehicles or vehicles with LiDAR for driver assist systems, the aesthetic is more important, and so that's another technical question that comes into play for these different approaches. And then the IP goals, certainly managing risk. There's so many new entrants in the space, lots of companies filing patents, many outside of the US, where it's not the new emerging technology is not in English, for example. Monitoring those quickly evolving technology approaches and the patents that exist, should they ever come into play in a commercial dispute, say IP dispute between commercial entities. It's better to be ahead of the game and not be blindsided as this technology continues to commercialize and become more widespread.
Well, Brendan, thank you very much for that. I just wanted to ask you a question. You mentioned the 5 LiDAR architectures that we're looking into. Should we be looking at others, or are those the 5 key ones that are key?
Yeah, that's a good question. At the outset of the study, we tried to identify what the key approaches were, and we feel pretty strongly these accurately capture the space at the moment. Certainly, there's always possibility of new architectures emerging, but generally, this is proven to capture the LiDAR space quite well. We certainly see some approaches in between, sort of hybrid of these different approaches, perhaps multiple of these different ones integrated together, or variations on these. But our classifiers that we built to capture the space have been very accurate in capturing those as well. And when we do our deeper analysis on the space, we're still able to pick those out and highlight those to participants in the study.
Great, thank you. Well, I guess talking about new technologies and the rapid pace of change, I'm going to hand over to Ben to talk about the accelerating pace of innovation in this space, because I think some of the insight is truly quite remarkable. Ben, over to you.
Yeah, thanks, Frankie. Thanks, Brendan. A nice intro to the space here. Yeah, when we talk about the accelerating pace of innovation, some of the questions to which we were seeking answers were, where are these new developments coming from a geography standpoint? Who are the leading companies in the space? And then what are the LiDAR technologies they're actually pursuing? So here is a good slide. We have this very apparent from the start of our exploration of this, that it is filled to the brim with different players. So we want to see how many new entrants it experiences every year, since there's a good metric to quantify the rise of interest and also competition in the sector. So here we have the number of first-time filers over the last 6-7 years, when they put their first application in place, and what countries these applicants originate from. It's really remarkable to see that we have such a steady increase of new entrants every year, with no leveling out in sight. Really, publications filed in 2021 are still surfacing, so this number will only increase as we go on here. The majority of new filers have consistently been from China, in red, with Korea in light blue, this teal color, being very much on the rise as well, and even on track to overtake the US as the runner-up here pretty soon. So yeah, another point, we expected numbers to fall off a little in 2020 due to the pandemic, but that wasn't actually the case at all. So yeah, just a staggering influx of new players in such a high tech field. It's quite unusual. Yeah, so the next question we wanted answered was, who are the top filers in the space and what technologies do they focus on? So here we have the top 10 filers with the total number of LiDAR patents identifiable by the beam steering technology that they pertain to. So the colors within the different portfolios indicate the beam steering variety. Looking through the list of companies, we see a very diverse field. We have big OEM like Bosch, LiDAR pure plays like Ouster, Blackmore, and Luminar, and also AV folks like Waymo, formerly Google's self-driving car project, a car manufacturer, GM, and then also non-traditional like Samsung. So quite unique to have such a split field in the top 10. Green and teal represent some of the more mechanically involved rotating platforms and rotating mirror LiDAR. And the top 3 filers focus heavily on those, with Waymo leading the pack. Dark blue, red, and orange are the more miniaturized LiDAR flavors, and since these are more recent developments, they naturally appear a bit low on the ranking just in terms of sheer numbers now. But good takeaway here, all companies have also filed on at least 3 different variations of LiDAR, almost all of them on 4. So betting all on different approaches here. Yeah, looking at the total number of filings is one thing, but exploring the timeline of filings can also yield some unique insights. So when did these companies file on them? Are there any changes in filing behavior? Always a good indicator for change. So here we have just the top 5 filers from the previous chart, applications over time, and again, color-coded by the different LiDAR beam steering technology. Waymo at the top, they started with rotating platform, added rotating mirror, and is more recently exploring more miniaturized versions. Good to note here, a little bit of background, for that huge spike in filings in 2016. Before that, they relied on Velodyne as a LiDAR vendor, and they dropped them in 2016 and moved that development in-house. So that's why we see huge increase in filings during that time period. Then Bosch here in the second here in the chart with some really early filings in the late 2000s, then dormant for a while until the AV craze began in the mid to late 2010s. And then they have a lot of filings on rotating mirrors, but also on the more integrated versions. So Flash and OPA we can see here represented as well. And then Blackmore, interesting because they jumped onto the scene in 2019 and then having incremental filings since. And Luminar stands out as the only one in the top 5 not pursuing rotating platform LiDAR at all. So they immediately jumped over that to pursue the more miniaturized versions. Yeah, for the last slide in this chapter here, I want to explore what technologies assignees from different countries focus on, and if there's a difference in protection when it comes to the publication country. So on the left, we see a breakdown of all beam steering LiDAR patents by priority country. So where were the first patents in the family filed? And then on the right, we have a breakdown of all the beam steering LiDAR patents by publication country. So where are these innovations being protected? So China is second to the US in both. About 25% of all publications in the space have Chinese priority now, and it's also the second most important country and market to protect, indicating a further shift from a manufacturing centric to an also innovation focused and technology hub, right? So another takeaway here, a large portion of the Chinese priority filings focus on more easily integrated solutions, MEMS mirror, and also solid state, like straight up solid state implementations, so optical phased array and flash. But overall, quite interesting that the split is quite even in terms of what technology to protect in the biggest markets, quite consistent with our findings that most companies don't put all of their eggs in one basket and instead bet on a variety of solutions there. Yeah, so that concludes some example insights, and back to you, Frankie.
Well, Ben, thank you very much. I think that does show, just even in terms of some of the shapes of your charts, the rapid change that is happening in the technology space. I just wanted to go back to something that you were talking about at the beginning. You were talking about the number of new players that had entered, and had entered from the point of view of that it was the first time they patented in the space. I was trying to top up your numbers, and it looked like it was potentially 300 companies in the last 4 years. Is that right?
That's right. Yeah, it's remarkable. 300 in the last 4 years, and those are just first-time filers. So they have been filing additional patents since they put those first ones in place. So the number of new patents being filed here, and also coming from new companies, people have never filed in LiDAR before, is significant. So yeah, all the more reason to stay on top of it, and makes it challenging, right? It's more important to keep on top while there's such a huge influx of new entrants, but it also becomes more and more challenging. So.
Yes, and I guess an interesting slide, because obviously a good number of those are from China as well. So yeah, keeping up to date with that. Well, great. Thank you very much, Ben. And I think through what we've heard from both Brendan and from Ben so far, it definitely seems like it's a incredibly active technology space, and one that you need to keep an eye on, otherwise you're definitely going to miss something. So what I'd like to do next is take you through how Global Prior Art and Cipher are going to address automotive LiDAR, because it is a large and very complex technology space. Before I do that, I just want to take a step back, because there are a number of different technology spaces that are pretty complex, are rapidly changing. And between Global Prior Art and Cipher, we've had a number of questions from our customers who are really trying to understand what's going on, because things are changing so rapidly. So in response to that, we've come up with the plan to launch a transformational technology and IP analysis service, of which the Automotive Lidar will be the first one that we're doing, to really try and help people get ahead, and to not be blindsided, to understand what's going on in these rapidly changing spaces. And for us, combining forces will bring something that's quite unique for everyone who's involved. Global Prior Art, as you've heard from presentations that we've had already, and when Bruce and Brendan and Ben introduced themselves, have really deep technological expertise. There's a lot of experience there that can really help customers get ahead and understand what's going on. And then when you combine that with Cipher's machine learning algorithm that can develop classifiers really efficiently and quickly in different technology spaces, and really be able to see any new trends or new technologies that are coming. When you combine those two together, I think it is something that could be very valuable for organizations, so that you are on the front foot rather than the back foot. But let's take ourselves back to Automotive Lidar and the study that we are doing. We're wanting to take a multi-client approach to this. So the idea is that we have multiple organizations who sign up to the study, and the ones who sign up first are able to really influence the focus and direction of the study, and really pose the questions that are really sticky in their minds, and they really want answered. We are proposing to cover a number of different areas. I've just outlined some high-level areas here in terms of obviously looking at what are the key trends in LiDAR. So how does that vary across technologies, across players, and across regions? And who are those potentially new emerging players or regions that we really need to be keeping an eye on? And how does that then translate into the actual products that are being developed? And what does that mean for the future LiDAR offerings that are out there? I'm now going to take you through in a little bit more detail some of the questions that we have heard from our customers who are keen to understand this space better. So if we're looking at just the technology landscape, and that would definitely be one chunk of this study, people are asking, you know, who are the players across these broad technologies? I think we've already seen with what Ben presented that a lot of the key players are in multiple technology areas. How does that also break down in terms of sub-technologies? Also looking at when the activity started. So I think, again, Ben, you showed us, you know, how certain players had built up in different technologies over time. And again, that gives you a view in terms of what the strategy might be. What are the inflection points there? And also, who are the new entrants who are coming in? That number again, which always seems to stick with me of, wow, you know, almost 300 or over 300 new entrants in the last 4 years. That is pretty staggering. So how can you understand that? And then you put that all together and you try and understand, well, where are the winning technologies in the space and where are potentially the waning ones? And what are those signals or red flags that we should be looking out for to make sure that you know, you are ahead, you understand what's going on in the technology space, and also understanding who's partnering with whom, how does that bring the technology to bear? So those are just a number of questions that we'd be looking at in the technology landscape. Next, we'd look at what's the strategic direction for the product itself. So how can filing strategies of players tell us what's happening? What are those new emerging players and what are they doing? Can we spot any trends? And can we look at these technologies to really understand what are the technologies that are going to accelerate product developments? And when you're starting to look at those technologies, how are they going to influence the vehicle design? How are they going to elevate the safety of that vehicle? And where are the key differentiators amongst the different technologies? And then also, what are the technologies that are really going to perform better when it comes to really difficult adverse conditions as well? What's interesting to look at as well when you're thinking about the strategic direction of the product, there are definitely differences between the regions, and how can we make sure that we understand, you know, what's going on in Europe versus Korea versus Japan and versus China. I mean, we've already talked about China having a large number of new entrants coming into the space. And then how does that all translate into the future outlook for the LiDAR product offerings? The final piece that we need to definitely look at is the corporate side of things. So let's have a real analysis of who the players are in this LiDAR space, looking at what's their history there in terms of filings. Have they got a particular regional focus? Have they had any litigation, and what's that resulted in? Has there been any change in their filing behavior that can maybe alert you to a change in strategy? And then being able to benchmark these players amongst their peer group and understand them better, which will all give us a view to understand what's their go-to-market approach. So I just wanted to show you one of the corporate snapshots that we're proposing, but I might hand back to Ben just to give you a bit more of an insight into this one that we're sharing here on Velodyne.
Yeah, certainly. So yeah, while patents provide the most detailed window in the technical solutions companies pursue, they often don't paint the whole picture. So with these corporate snapshots, we gather and add non-patent data in order to provide some more context. So here's an example of Velodyne, one of the founding fathers of automotive LiDAR. We identify what kind of assignee it is, whether it's an operating company or academic institution and so on, also what type of industry it's operating in. Below that, still in the upper half, we can see the timeline of filings and breakdown by beam steering technology, and then alongside an overall overview of the portfolio. So it's a quick fingerprint that allows us to identify focal points and also changes in the filing behavior. So I mentioned earlier that Velodyne and Waymo used to partner up. So that was before 2016. And then we see here this kind of reactionary increase in filings in 2017. It's almost like they're resting a little bit on their laurels before then, with only a few filings before 2016, and then want to really increase the activity there. And then in the lower half, we present the partnerships they have entered in, as well as any products currently on the market. And then we round it out with some of our insights or news, such as any litigation that has occurred or is currently going on.
Great, thank you, Ben. And just the final piece I want to talk about the study is there's no point in us delivering a study to you and boom, that's it. It's all done, because as we've been highlighting, I think throughout the time that we've had together so far, this is a rapidly changing space. 300 new entrants in 4 years. I'll go back to that. We need to keep you updated, and therefore we're proposing a quarterly update which will highlight the key changes. So whether that's new players entering the space, new technologies, any asset reassignments, again, key just to get you ahead in terms of these are the key focus points that and inflection points that you should be looking at. So that hopefully gives you a good overview of the study and what we're thinking in terms of questions that we're going to answer. I now would like to pass you over to Bruce, who's going to take you through some of the benefits of the study approach and what we feel you'll get out of it. Bruce, over to you.
Thank you, Frankie, for a great overview of the study findings. Let me briefly just talk a little bit about the benefits participants will receive from the study approach. One, it's an independent perspective. And as Ben and Brendan have mentioned, this is a rapidly changing space, and it's key to avoid being blindsided. It's key to have a way to keep on top of all the change, and it's going to be hard to do that independent by yourself. What we saw when we did the 2018 study is a lot of the players were blindsided by the emergence of solid-state LiDAR. Companies tend to be too close to the technologies that they're focused on, and they miss critical changes. It's also a very robust approach. It combines machine learning and subject matter experts, so you get the best of both options. Machine learning and its efficiency to identify the relevant patterns. And for the last mile, you've got all this great information, but you really need subject matter experts to go through and to glean the important findings and trends and insights that you really need. And that's really going to be critical. So we have, well, a concept of what we call insights travel, that you're going to get findings like the scorecards, easy to see what's going on, easy to understand your position. If you're in R&D management or senior management, you don't have to read patents because Ben and Brendan are going to go through those materials and extract all the valuable insights on technology shifts and all the key details that are so critical that you want to know what's important, but you don't want to spend time going through that information. And so with the concept that we have of insights traveling, Ben and Brendan are going to be doing the hard work to get you through that last mile so you have the information you need at your fingertips. It's also important to understand you're going to get deep insights. So it's not enough to say, this company has X patents and that company has 2X patents. At the end of the day, it's really important to understand what the patents actually cover. And, so even if they're not cited a lot, they could be really important patents. You could have portfolios of 3 or 4 patents, which are really important. So you need to understand that. And that's what we do as subject matter experts. The findings are going to be highly relevant. We are gaining the insights from all the participants in terms of some of the key issues that they would like addressed. And on top of that, through the initial work that Ben and Brendan have done, we really have the basics of the space and the key technologies and sub-technologies and product features. And so it's going to be extremely relevant. it's also going to be critical customer information that's not available anywhere else. That's really important to recognize. The other thing we hear from people signing up, they realize this is an approach that would be difficult for them to achieve in-house. It would mean they'd have to divert key internal staff members from R&D and the IP groups for an extended period of time, and would be very expensive, much more expensive than joining the study. Let's think a little bit how this information will enable you to make better decisions. And so what we have here is really the information that you're going to need to make decisions about your technology landscape and R&D management. It's not just the information itself, but we're going to tell you what's important in terms of the trends and the insights. And Brendan and Ben are there to walk you through in terms of what's really important, what you need to know. You're going to get all the information you need for effective decisions for these, based on understanding the strategic direction of LiDAR and product innovations. As we've heard in the first two parts, it's really key to understand which technologies are going to enable you to get smaller form factors and allow you to have better safety and to have a competitive edge. And that's really going to be important. That's what's going to come out of that part. The detailed information allows you to do gap analysis and IP prioritization. You know, it's so critical to understand how you shape up and where your strengths are and weaknesses are. And to do that, you could do it analytically with the knowledge from the study and the gap analysis that you could conduct with that information. You know, everyone talks about the critical importance of having proactive strategies. But proactive strategies actually require this body of knowledge. And so this is going to give you the knowledge to create proactive strategies and be able to really capture IP and technology opportunities. And lastly, there's going to be exposure to best practices. One of the things we've seen is that companies that have this type of information, it not only allows them to do proactive strategies, but they think about how this knowledge can transform their approach to R&D management, to product development, to the way they file patents. Even they're thinking about creating portfolio analysis. And so it just elevates the performance of a company to a much higher level. It creates what we call a knowledge-based organization. So yeah, with that, let me turn it back over to you, Frankie.
No, well, Bruce, thank you for taking us through that. And I think one thing that definitely struck for me is that taking an approach like this allows you to be proactive. I guess there's probably a sense that maybe people are reacting to things rather than actually proactively planning, and therefore reacting cannot always be the best approach.
Absolutely.
Yeah. Well, thank you very much for all of you for giving us those presentations. We've now got some time left for questions. So I'm just going to have a look and see what we've got coming in here. There is a question around, well, I'll take this one first because it's around the actual the study that we've just been talking about. And Bruce, I might or I might take the answer to this one. So somebody is asking if the study will be private. So I assume that you mean, you know, if you sign up for the study, will you know who the other participants are? or will it be public? It definitely won't be a public study, and you won't know, and other participants won't know that you've signed up for the study. So there will be complete privacy there. I think what you will benefit from, obviously, is having the questions and focus areas from different study participants. So you'll get a wide range of analysis that comes out of that. So yeah, that's one question. We've also had another one, I think, Bruce and Brendan, you mentioned it as well, that I think you wrote an article in 2018 about something that had happened in the LiDAR space, and people were blindsided. Could you maybe talk a little bit more about that? Maybe Brendan, we'll start with you.
Yeah, in 2018, what we really took away from our look at the space at that time was that solid state LiDAR was a budding technology, and that it was really emerging as a new solution. And we anticipated a lot more attention to that going forward. And we saw a lot of the players that were already filing and active in LiDAR focused on the mechanical solutions, the spinning LiDAR platforms, or architectures rather, and not filing at all in solid state technologies. So we anticipate that could potentially even overtake the other approaches. Interestingly, since then, we've seen that the larger mechanical solutions, spinning LiDAR, continue to receive a lot of attention and continue to mature. But the solid state solutions kind of catching up and progressing alongside those existing approaches. Ben, I know you looked at the space a lot at that time in 2018 and since with me. What are your thoughts on those developments?
Yeah, I think what was interesting with the mechanically rotating LiDAR units, they were at first prohibitively expensive, and I believe Waymo then made some internal improvements on those. So they apparently had a breakthrough in just how they aligned the optical components so that the manufacturing and calibration was much cheaper. So that really dropped the price. So also explains why they keep continuing on filing on those more mechanically involved LiDAR units, because they did make some good improvements that are still able to compete with the newer budding technologies there.
Great, thank you. And Bruce, I think you're still there, but we can't see you unfortunately anymore. But would you add anything to what Brendan and Ben have said around what happened in 2018?
Absolutely. So a number of the companies reached out. They had read the article, and they were really complimentary, and they pointed out, they were really surprised that they were blindsided. And what has happened is companies, the way they go about doing R&D management and R&D planning, product planning, is they reach out to the people on their product development team, R&D teams, and there's a tendency to basically fine-tune what you're already doing. And Ben mentioned this, how the people that were doing mechanically spinning LiDAR basically were trying to fine-tune what the performance of mechanically spinning LiDAR. So companies don't really do a good job of asking the right questions. And so one of the reasons that you're blindsided is you don't really have information coming in about competing technologies. And that's what this study does. It means that if you're the R&D head, you've got the information about alternative options, and you could ask really key questions on, what is the likely progression of the technology that we're betting on versus some of these alternatives? Where are we going to be in terms of form factor and performance? And so it really elevates the way senior management could think about oversight and make key decisions when they bet big bucks in terms of product development and the technologies that they want to foster.
No, thank you all for illuminating us on 2018. No, that it does seem like it's about making sure that you're asking the right questions. We've got another question in here, which I guess is probably quite current. What are the implications of the Velodyne Ooster merger? Ben, do you maybe want to kick us off on that one?
Yeah, that's very timely. That happened 3 weeks ago, something like that, 3.5 weeks ago. Yeah, so Velodyne and Ouster, they announced that they're merging, coming out as kind of an even split between the parties. So I'm sure there's some economics heavily in play, but makes sense from an IP perspective too. So they have pretty similar portfolios where they focus a lot on these rotating platforms, so similar product offerings. I believe Ouster had also a recent acquisition of a more flash-based focused company that was just on the heels of that. So not only boosts their kind of complementary portfolio as a combined company, but they also add now, like Velodyne, Ouster, and the other patents now add quite a significant portion in the flash space. So yeah, first signs of consolidation here for some of the players. Yeah, to widen their product offerings, more robust stance in terms of IP and protection and so on.
Brendan, what's your read on the merger?
Yeah, quite interesting. Two large players in the space joining forces. We've seen a few other transactions, mergers and acquisitions by some of the leading companies in the space. Often they've been to fill gaps in the portfolio. As we mentioned in 2018, the emergence of solid state as an innovative solution and for LiDAR, solving some of the issues that the current approaches at that time were focused on. And there's one approach is to just go acquire patents as opposed to in-house develop a solution and join forces. So there's been a number of transactions for that reason as well. Interestingly, patents haven't been reassigned for a lot of these mergers and acquisitions, and so that's something that we're keeping an eye out for in terms of what technology reach different companies have in the space, because the patent information on the face value doesn't give you a full picture. And so we're keeping careful record of the partnerships a lot, as well as the M&A transactions to help stitch together a more insightful picture of the technology reach actually of different players in the space. It really kind of shifts maybe how you might think of how players are positioned and what the different approaches are. Even still, there's a lot of risk potential with all these new players entering the space. M&A might plug some of the technology gaps, but as we've seen with a lot of other technologies, patents filed by smaller startups and non-practicing entities during those early phases can be valuable assets down the line that are asserted against some of the winning commercial players. And so keeping an eye on that while these commercial transactions are happening, following the IP transactions to see what patents are still possible risk and where those lie. I think it's very important and highlighted as well by companies filling gaps with M&A, like the Velodyne Ouster partnership there.
Yeah, Ouster is already in the top 10. It will change the picture quite a bit now with that once the merger goes through. I think it's next year. Yep.
Great. Well, we haven't got a lot of time left, but I want to squeeze in one more question, if that's okay. Somebody's asking, what do we think of the waning technologies? Bruce, I didn't give you a chance to answer the last question, so I might give you first dibs on this one. What do we think are the waning technologies? Is there an easy way to answer that?
Yeah, I think what's really interesting is over the next 3 years, we're going to see sort of a customization of applications. And I think it really goes to the merger that was just discussed. we're going to see certain technologies are going to be really ideal for vehicles, certain other technologies are going to be great for trucks, and some other technologies are actually going to be very useful for some military applications or mining applications. And so I think that's going to be one interesting thing that the study is going to sort of highlight, is sort of this customization that's going to take place. Frankly, if I may, the question before dealt with the privacy question. And I think one of the things we want to do is, I know some questions that participants have are really quite sensitive. So we're going to have really a wall in place between the people that sign up so that they'll be able to have their questions answered in a one-on-one discussion. So there'll be complete privacy about who participates, and we'll have some walls in place when their sensitive questions are asked.
Wonderful. No, yeah, thank you for coming back to that, Bruce. Unfortunately, I think that's all we've got time for in terms of questions. I think we've got one or two more that we didn't manage to get to, but we will definitely get back to you with those answers. But I do want to round us up today with just some key takeaways from the team here. So Ben, maybe we can start with you. What's been your key takeaway for everyone today?
Yeah, for me, it stands out is it's a very unique space, LiDAR. It's not only just rapidly evolving, but also so fractured in terms of different players that are active, and they all come with their different philosophies and patents and IP. So imperative to stay on top of it and all the new developments.
No, that's definitely true. Brendan, how about you? What would be your key takeaway?
I would just reiterate, LiDAR is a very exciting technology and quite young actually in development, following a cycle that we see early on for commercialization of technology. And so that is a huge influence on this rapid acceleration of filings in the space and evolution of different LiDAR solutions. And it's going to be a critical technology for future vehicles. And so we're going to continue to see a lot of changes emerging, and with this rapidly evolving landscape of technology, having a combination of subject matter expertise and patent classifiers really helps keep up with things. And we've certainly been very excited to look at this space and help out the participants in the study.
Thank you, Brendan. And finally, Bruce, what would be your summary of today?
I think there are a number of key takeaways. We mentioned how combining Cipher's machine learning based classifier with the deep subject matter expertise of experts, it's yields a very powerful approach that allows accurately capturing and analyzing this really large, complex, rapidly changing space. And that's really the key part to start with, because without that, you really cannot do the deep analysis that we talked about. And the deep analysis, which is going to get us the last mile, by going through all of this really rich data and patents and some products, it's going to yield critical information and insights which are not available anywhere else. And so it's really exclusive information. And it's information that would be really very difficult and challenging if a company tried to do this in-house, and really requires just diverting key resources. And the independent approach has really important benefits. You're not going to be blindsided. You're going to have a way to constantly keep up to date with this rapidly changing space. And you're going to have the information that's needed for putting in place proactive strategies. And we talked about it's going to be detailed information that allows making decisions based on knowledge of the strategic direction of LiDAR, or technologies, decisions based on understanding the technology space, which is so key for effective R&D management and for filing effective patents. We've also seen that the availability of this critical information supports a transformational approach to enhance decision-making by allowing a knowledge-based company. So the goals and the roadmap that we've talked about are sort of highlighted by the famous quote by the eminent management guru, Peter Drucker. He said, the best way to predict and create the future is to create it. So today we discussed a study which will provide the tools, analysis, and the insight needed to not only predict the future, but to create it and to capture it with strong patent assets.
Well, thank you, Bruce. That was a great wrap up, I think, and definitely a good summary of what we've covered today. That's all we've got time for today. So thank you all for listening, and a big thank you to our presenters today. We will be sharing the recording, and please do get in touch with us to find out how you can get involved in the study, or if you have any other questions around the LiDAR technology space. And we look forward to speaking to you soon. Enjoy the rest of your day. Bye for now.
Bye-bye.